Alrighty. Hello. This is the project demonstration for the CS631 company personnel database project. We are both going to share our screen in a moment and display what we've worked on um, to fulfill the requirements for the project. All right. I will begin by sharing my screen in a moment. Alrighty. Can you see my screen?
Yes, okay. Let's see.
Perfect. Perfect, perfect, perfect. So we're going to start here with the company database system. This is what we have built. So this project is a web-based database application built using PostgreSQL and Python with Flask. It implements a complete company personnel system with two main applications, human resource management and project management. The system demonstrates a full two-way interaction with the database, including creating, retrieving, updating, and deactivating records through a browser-based interface. So I'll walk through the system from start to finish, showing how data is entered through the web application, how success is confirmed, and how the database reflects those changes. So first, we're already on the home page. This is a main landing page, by the way, of the web application. So from here, users can choose between the HR management application and the project management application. Both connect to the same Postgres database. So let's begin with the HR dashboard. Here we go. It's very simple. From here, users can add new employees. They can view existing employees, promote employees, and view payroll-related information. So let's begin by adding a new employee. So here, you can add any employee number you wish. I'm going to go ahead and add something like 0616. Going to add my name and my job title. Let's say customer service, salaried with an annual salary of, let's go ahead and say $40,000. Department ID, 1, with a start date of today and add employee. All right, so here I am, employee 616, Nat Lewis, customer service, salaried for $40,000 a year. Successfully added. Okay. So here, everything's input simply. When a form is submitted, the application inserts a new record and automatically creates a corresponding job history record to track salary and title. Now we're going back to HR management and we can view our employees here. As you've seen, we have 36 total employees. This actually can be retrieved using the database. We'll actually take a look at that later. Let's go back to HR management and decide to promote an employee. So let's say I would like to promote myself, right? New, new job title. Let's say CEO, right? And I want to promote my salary as well. We're going to go ahead and put it at all of these zeros. Yep. Effective today, promote. And I've just promoted myself to CEO with all of that salary. So the form demonstrates updating existing records. When a promotion is submitted, the application inserts a new job record into job history table and marks the previous job as inactive, which preserves the historical data rather than overwriting it. So I didn't want to delete any records from employees. We didn't want to delete employee titles or previous salaries. Rather, that goes into our job history. It is never fully deleted. It's rather preserved, and things are changed instead of completely deleted from the system. So as you can see, it worked. That is generally the function of the HR management application. So we're going to move on to project management. Here you can see we have a couple of different more options. Um, this is the project management application in general, which handles projects, team assignments, hours tracking, milestones. So to create a new project, this displays the create function of CRUD. Project number, let's say 9. Project name, let's why not? And the budget, let's say the budget for this is $60,000 starting today. The project manager on this, why not use the same number, use my number, department ID 1. Okay, so as you can see, I have become the manager of this project in the software development department, which is 1. The form created a new project. It inserted a record into the project table and associates it with the department and a project manager. Now we can go back to project management, view all projects, and see that that's been updated here as well. Now let's see about the other features, assigning an employee to a project. Of course, we could use the same ID. I'm already the project manager, but let's try and assign myself to a different project, right? Let's try to assign ourselves to project 8, role on project, developer, starting today. Assign. See, I am the manager of this one, but I'm also featured on this project. Assign employee 616 to project 8. So to complete some more of our features, we can complete a milestone. We can, of course, update the project hours if, if we chose to, right? So let's say employee 616, project number 8, hours worked, 12, update hours. That's been updated. Going back to project management, let's complete a milestone. Let's review our milestones, all of our projects in progress, some pending. Let's choose a milestone to mark as completed, right? This feature is very simple. Instead of deleting data, the system updates the milestone status, which again preserves the historical project information. So let's pick this one, 11, prototype development, project number 5. It's currently in progress. Let's pick a date. As of today, been completed. Successfully completed milestone 11. These are our total projects. Okay, so right now this is the application side of the project, but for a second, let's take a look at PSQL. So these are a couple of queries I had originally run just to kind of get a feel of the information in the database. So as you can see, I have a query here that selects the employee number, name, title, employment type from employee, and that just gives you a sense of who works at this company. Again, we have a prior query with department ID, name, budget, tells you a little bit about departments. Here's another one that tells you about the divisions. And we have some more up here that give you a join, which selects the project as well as the employee that is working on it, the manager, right? So let's go ahead and just cycle back through some of these, like this one. As you can see, Nat Lewis in the software development department. So these are some queries that we're running that prove that we have both ends of the database constructed. So this project just demonstrates a fully functional web-based database system with 2 applications. As you can see, users can create, retrieve, update, and deactivate instead of delete records through a browser interface, and all changes are immediately reflected. The design follows proper relational modeling principles, enforces data integrity, and preserves historical records. This is the portion of the presentation that displays the function of the database system, and I will now pass the baton to Vivian, who will then explain the structure behind it. Thank you.
Thank you. Yes, so I'm going to go over the structure behind this whole web application with the ER diagram and the logistics of how this is going to work. And I'm going to share my screen. Let's see. Okay. Screen, can you see my screen?
Yes.
Okay. All right, we can see the ER diagram. Cool. Okay, so for this ER diagram, I'm going to go over the step-by-step mapping on how we can create this ER diagram. And the first step, we're going to identify all of the strong entities.
Mm-hmm.
Now, the strong entities are basically entities that can exist independently with their own primary keys.
Mm-hmm.
So they don't need to be dependent on other entities, which we're going to identify the strong entities first in this database, which is the employee title, and the division, department, projects, buildings, because they can exist on their own. They don't need to
Mm-hmm.
depend on anything to exist.
Right.
Right. So then the next step that we would do is identify the weak entities. And weak entities are the ones that are dependent on a strong entity. So they cannot exist without depending on another entity,
Mm-hmm.
which would be the rooms, because the rooms cannot really exist without a building. You would need a building first in order to have a room. And project milestones, because you would need to have a project exist first before you could have a project milestone. So it is dependent on the project. Payroll history, which is dependent on the employee, because you cannot really have a payroll history without the employee. And a job history, because uh you need the you need an employee in order to have a job history for the employee.
Mm-hmm.
Now, the next step into creating this ER diagram is identifying the one-to-one relationships. This means that, so for example, in our ER diagram example, it would be one employee to one division. You cannot, well, we're not going to have like multiple divisions for one employee. So we're going to identify all of the relationships that are one-to-one, which in this case, you would have one employee per department, and then one employee per division, and then of course sometimes an employee would not have a department and work for a division.
Mm-hmm.
And then we also have one project per employee as well. So we would have, sorry, it's kind of hard to see here, but you would have one employee works on one project here. Just an example. And then the next step would be to find or to identify all of the one-to-many relationships, which is in our example here, it would be like one division has many departments. So right here, I have, I'm going to, right here. Oh, that's not supposed to happen.
Yeah,
So,
I'm
yeah.
following.
Okay, so this would be one division has, oh,
Every division
We,
has a department, right?
yeah, yeah,
Okay. And every department has a room. Every building has a room.
right. Uh,
Okay.
right. And then one building can have many rooms, which can
Mm-hmm.
be used for offices or conference rooms.
Mm-hmm.
So right here, it would be this one building to N, which is the one-to-many relationship,
Mm-hmm.
way to denote this. So it would be one building to many rooms. And then the fifth step to this ER diagram is to identify if there are any many-to-many relationships. Things can, so multiple entities could have a relationship with multiple entities.
Mm-hmm.
So this could be, mm, I don't think we have any many-to-many relationships on this ER diagram. So we do not have that here. So we can go on to step 6, the multi-valued attributes. Now, multi-valued attributes are essentially just attributes that can have more than one value for a single entity.
Mm-hmm.
So, for example, not related to this ER diagram, but just as an example, a student can have multiple phone numbers if they were to make multiple phone numbers.
Right.
But in our case, in this diagram, we do not use any multi-value attributes,
Mm-hmm.
because one employee would be assigned to one phone number.
Mm-hmm.
We don't really have any employees that would have multiple phone numbers here. And then the next step would be to identify any higher order relationships. And these are just basically relationships that involve three or more entity types at the same time.
Mm-hmm.
So, for example, if you have like, again, not related to this specific ER diagram, but like if you had like an enrollment program where you would have like student, course, and semester, and they all tied together to one relationship.
Mm-hmm.
But we do not have this specific example in this ER diagram, so we do not need to draw any higher order relationships here. And then the next step is to identify if there is any specialization hierarchy that is being implemented, which is basically when you take one general entity type and you split it into more specific sub-entity types or subclasses based on distinguishing characteristics.
Mm-hmm.
For example, if you had an employee, but then they were like a full-time employee or like a part-time employee. But we also, for this specific diagram, we also did not have any specializations. As you can see, the most that we have is like a job history, which doesn't really count as a specialization. It wouldn't be considered a subclass or a sub-entity in this case.
Okay.
So we can kind of move on from that. And then the last step is to identify any aggregations and if any aggregation relationships were used. And this is basically just when you treat a relationship set as like a higher level entity so that it can participate in another relationship.
Mm-hmm.
We also do not we do not use that.
Is there anything else you'd like to cover?
No, I think I'm good.
Okay.
Mm,
Perfect. All right.
yeah,
That concludes the presentation of our project, our database management. As you can see, we've both included the full database explanation, both the front end and the back end querying system, as well as the step-by-step mapping and overall entity relationship diagram. This concludes our recording, and thank you for your time.
thank you.